Now our ninth problem type, you should be able to find increasing and decreasing intervals and any relative extrema. Now this, you might be given a fraction or maybe even a polynomial. Usually I don't put a radical on tests. They're just a little bit too hard for a 50-minute test. So let's look at that. Got f of x is equal to x squared minus 2x plus 4 over x minus 2. And find intervals where it's increasing, decreasing, and relative extrema. Well, we have to use the quotient rule here. Top is p, bottom is q. So p prime would be 2x minus 2. Q prime would be 1. So p prime q minus p q prime over q squared. So for our first derivative, p prime was 2x minus 2 times q, which was x minus 2, minus p, which was x squared minus 2x plus 4 times q prime, which is 1, all over q squared. Let me double check that. P prime 2x minus 2 times q, that minus p. Okay. Now, I would factor out what they have in common, but the first group and the second group have nothing in common. So I just want to get rid of parentheses, combine together like terms, see what happens. 2x times x is 2x squared. 2x times negative 2 is negative 4x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. A negative in front of your parentheses flips the sign of everything inside. So it becomes a negative x squared plus 2x minus 4. All over x minus 2 squared. Well, up on top, 2x squared minus x squared gives us x squared. Negative 4x, negative 2x, and positive 2x gives you negative 4x. And 4 minus 4 drops away. Let's make sure I got all my terms counted for. Yep. Okay. Well, the top part we can simplify a little bit. We can factor an x out. Our hope is that it will cancel with something down below, which in this case it doesn't. Okay, so now we're ready to find our critical values. And I'll do it up here. When you're dealing with a fraction, to find your critical values, you set your top part equal to 0 and you set your bottom part equal to 0. So we're going to take x times x minus 4, set equal to 0. And we'll take the x minus 2 squared and set equal to 0. Now, x times x minus 4 is already factored, so all I have to do is set each factor equal to 0. So I'll set x equal to 0 and x minus 4 equal to 0. And this one here, I can drop the squared. Remember, if you got parentheses to a power equal to 0, you can drop the power. So we got x minus 2 equal to 0. So I got 0, I got 4, and I got 2. Those would be my three critical values. So, let me set up my intervals. And let me do it down here, so I have room. Smallest one is 0. Our next one is 2, and our next one is 4. Clear over here is negative infinity, and clear over here is positive infinity. Now I'll pick test cases. I'll pick a number between negative infinity and 0, like negative 1. Something between 0 and 2, like positive 1. Something between 2 and 4, like 3. And something greater than 4, like 5. Now we want to plug them into our derivative. And probably the easiest one to work with is this one right here. Now look at the bottom part, x minus 2 squared. When you square something, it's always positive. So I don't even need to worry about the bottom part. I'm just going to plug it into the top part. X times x minus 4. Same on all these. The denominator is always positive. All we care about is the sign of our answer. We don't care what the actual value is. Saves you so much time if you keep that in mind. Okay, So let's plug in negative 1. So we have negative 1 times negative 1 minus 4 over positive. Well, this is negative. Negative 1, negative 4 is negative 5. That's negative. Negative, did I say that was positive? That's negative 1. That's negative. And this is negative. Negative times negative is positive. Positive divided by positive is positive. So this is increasing. If I put 1 in, I got 1 times 1 minus 4 over a positive. 1's positive, of course. 1 minus 4 is negative. Positive times a negative is negative. Divided by positive is negative. So it's decreasing. If I put 3 in, 3 is positive. 3 minus 4 is negative. Positive times a negative is negative. Divided by positive is negative, so it's decreasing. And if I put 5 in, 5 is positive. 5 minus 4 is positive, so this is positive, so this is increasing. Okay. Let me write down my increasing, decreasing, and so forth. So it's increasing from negative infinity to something. Scroll up a little bit. Okay, our first critical value is 0. And then it's decreasing from 0 to 2. Then it's decreasing from 2 to 4. And then it's increasing from 4 to infinity. Now those are our intervals where it's increasing and decreasing. Now, our relative min, relative max is where it changes from increasing, decreasing, or vice versa. So this is increasing, then changes to decreasing. So this is going to be a relative max, assuming our graph exists at 0. And we'll go check that here in a minute. Now here it changes from decreasing to increasing, so this will be a relative min, assuming it exists at 4. Let's go up and look at our original problem. Okay, the only place it's undefined for our domain is x cannot equal to 2. So those are fine in terms of min and max. So we're going to have our relative max, x is equal to 0. And we'll have our relative min at x is equal to 4. And we want to plug those into our original function, this one here. So I got f of 0 is equal to 0 squared minus 2 times 0 plus 4 over 0 minus 2. And this one will be f of 4 is equal to 4 squared minus 2 times 4 plus 4 over 4 minus 2. Okay. These zeros drop away, and we got 4 over negative 2, which is negative 2. So our relative max is at 0, negative 2. Here we got 16 minus 8 plus 4 over 2. 16 minus 8 is 8, plus 4 is 12. 12 divided by 2 is 6, assuming I didn't add or multiply or something wrong. So this relative min would be at 4, 6.